symptoms. And that really created the foundation for a hypothesis that these were deficits in these brain neurotransmitters. Problem is just filling up the tank didn't keep you well, and that it really didn't accommodate the course of illness for many people. But it did drive a lot of very, very good neurobiology to understand the important role of serotonin in mood regulation, and how it strengthens.
It was therapeutically very helpful for many people.
And that's the most critical point, is despite the fact that it doesn't explain all of the biology, it has changed the lives of so many patients. And as a neurologist, we're interested in not just what chemicals, but where the chemicals act. And like every other neurological disease, where in this one, in the case of depression, you have a mood problem combined with slowness of movement, motor changes, a change in cognition, people are slow thinking, as well as disorganized, but not like we're going to hear about psychosis, as well as a dysregulation of circadian systems. Your sleep is off, your libido is off, your appetite is off. These are behaviors that we know a lot about where in the brain they live. And with the advent of neuroimaging, it was possible to test those kinds of hypotheses. Not so much chemical, but what brain regions are in what. And with tools like positron emission tomography or PET scanning, or functional magnetic resonance imaging, fMRI, we can literally map the brain in action and know exactly our brain areas that we describe these behaviors to. Are they overactive, underactive, and we can start to map precisely how the brain circuits that mediate this disease are.
How many experiences in which she came into the field of psychiatry, being a neurologist, and so she was interested in the kinds of things we've been talking about. Where is it located? And she was the first person to find a biological marker, an area in the brain that was abnormally active in depressed patients. Do you want to discuss that?
Well, again, I mean, we as well as many other investigators using imaging, we're really trying to take groups of people who had classical symptoms, not on medicine, and literally see what was wrong with their brains. Are areas overactive, underactive? Is it one area or another area? And our work started to focus not just on one area, but one area became very much critical. It's an area called the subcallosal cingulate. And what we found was that its activity is overactive in people when they're depressed. And at the same time, there's actually an effect on the frontal lobe, the thinking parts of the brain, that are underactive. So there's almost a tug-of-war, as the patients describe, where there's psychic pain, a very active state of suffering, that we think is really driven by this subcallosal.
This was a fantastic advance, because it was the first time one had a really good